great. Thanks everyone for coming. Good afternoon. So we are in Introduction to Applied Data Analysis. So I'm Alan Jen. I'm a professor in the Civil and Environmental Engineering departments. And so this is a course that's been, I think, growing a little bit in popularity over the years. This is really motivated by when I was in grad school, taking a bunch of like stats courses and econometrics courses. You know, I learned all this stuff about regressions and like the theory behind a lot of this, but kind of less practice in being able to like apply it myself. And so this course is designed to help essentially do that, right? And so we're going to teach a bunch of techniques here that are meant for you guys to be able to employ if you're doing any data analysis in your own research. So I'm going to quickly go over some course logistics. So all of this information is going to be available on the Canvas if you haven't looked at it already. Most of the logistics is on our syllabus. Classes are here, obviously, from 2 to 4, Monday, Wednesdays. Feel free to reach out to me on Canvas or by email. We do have one holiday, May 27th, so keep that in mind. So a couple things about our overview. Again, this and a little bit more detail on what's actually covered week to week is all on the syllabus. So the first 2 lectures, which is this week, Monday and Wednesday, we're going to do an introduction to R. So this class tends to draw a pretty interdisciplinary crowd. So who has never used R before? Okay, a good portion of the class. Who has programming experience but not in R? Anyone? A couple people? Yeah. And then who has done R work before? Yeah, okay. So what I will say is this. So for the folks who haven't done R before, don't worry, you're gonna be fine. I will say that the amount of time that you spend on homeworks is probably gonna be a little bit more than other folks, but I will say that many people have taken this class without any programming experience at all, and they've done perfectly fine. They have had to spend a little bit more time, but that's kind of the nature of kind of learning this on the go. For the folks who have like Python experience or something like that, but haven't worked in R, so I think you'll find that that transition is actually pretty easy. You just have to learn a little bit of syntax, but I will say that if you want, I don't care that you do it in Python, but if you choose to do the work of this class in another programming language, it will be a little bit of extra effort, right? Because there's going to be some customized packages and stuff like that. But that's a little bit more accessible in R. So I'll leave that up to you guys, however you want to do it. And then lastly, for the folks who have experience in R, you know, the first 2 lectures are hopefully going to be kind of a refresher for you. But there may be things that you'll be learning anyways, right? Then the rest of the class, it's going to be kind of divided up into like a 50-50 kind of board work and then application in R. And so every time we go through like a technique on the board, we'll then do examples like in class, and everyone can follow along. All the notes and all the code that I produce during class are going to be posted online. I've done this for a couple years now, and so the notes are pretty thorough, so make use of those resources if you need. It'll be in the files under Canvas. Lastly, there's going to be a couple weeks, actually, or there's one particular week that I am out of town, and so those lectures are actually going to be covered by our TA, Yanni, in the back. Say hi to everyone. Hi, everyone. Yes. So speaking of which, our office hours, so my office hours are going to be on Thursday mornings from 10 to 11 in Gaussy. And then Yanning, our TA, she's going to have office hours from 3:30 to 4:30 in the afternoon on Tuesdays at West Village in the EB Research Center. Hopefully you guys can figure out how to get there. And if you can't make these times, we will try to make ourselves available when possible. possible, so you can feel free to email either me or Yanni. Any questions so far? Okay. Yeah, in terms of grading, most of the grade is going to be in homeworks. So there's going to be 4 homeworks. It's going to be worth half of the grade in the class. You have about 2 weeks each to do them. 5% deduction per day late. There's going to be like a wishy-washy participation score. Don't worry about that. Final project. Yeah, so this is 40%. Okay, so what I will say, final project is going to be a little bit different. If you noticed in the schedule, we have project presentations on the last week of class. Usually this class is like 20 to 30 people, but for some reason this quarter we've got 50 people, although it doesn't look like there's 50 people here. So we'll see what ends up shaking out. That actually means that the presentations at the end are not all going to be able to fit into that last week, because we want to give everyone a chance, some amount of time to actually present. And so probably what we're going to end up doing, what we're going with, is some people will present in person in that last week, and then I'm going to ask the rest of the groups to record themselves. I think that's how we're going to do it, but we'll stay tuned and see what actually happens with the class size and everything. Yeah, and that's pretty much it for the logistics. Again, any questions? Okay. You may have noticed that we are recording, and so how that's going to work is I typically will record the classes and just post them on YouTube, and so that is a resource for people if you want to review material. If you've missed a class or something like that, it's available for you to use. Obviously, I kind of prefer that you come here in person. I think it's a better experience and you have the opportunity to ask questions and that sort of thing, but yeah, if life happens, whatever, and you need to watch it online, that's fine. Yeah, and all the details on that stuff will be posted on Canvas. Okay. If we have no questions about course logistics, then we can go ahead and jump right into the material for the first week, which, as I was mentioning, will be focused. Oh, yes.
Can we get more details on the project? So what's expected out of the project?
Yeah, so actually, I'm going to talk about that a little bit more later on, but if you want to know already, if you're like burning to know what's going on with the project, the rubric for the project is already, is it already posted? If not, I'm going to post it today on Canvas, and that's going to give a breakdown for the 3 main components of the project, which are your a proposal, which will be like halfway through the course, you have to submit a proposal. That's so that everyone's not doing it totally last minute. I can give a little bit of feedback on what you're doing and if that is enough or too much or too little for the class. And then besides the proposal, the 2 main components are going to be presentation and report. And the project can be done in groups. Actually, we're going to probably mandate that it be done in groups, otherwise there's going to be too many. So probably at least 2 people per group. Again, we'll see after like 1 or 2 weeks how many people are in the class. Anything else? Any other questions? Okay, so we're going to get started here. Oh, hang on. I'm supposed to record the screen. Oops, 1 sec. Okay. Good thing we have the backup already. All right, so then we can maybe just splice these together. All right. So, hopefully everyone got the announcements. If not, just do it really quickly right now. Please go ahead and download and install both R and R Studio if you haven't had the chance to do it. And then I'll kind of walk through this, and you guys are welcome to kind of follow along as we do some basic coding. So this is the user interface for R Studio. I often recommend this, especially to people who are kind of either using R for the first time or even programming for the first time. The user interface is a little bit more friendlier. It's got, you know, some ease of use features, like auto-completing functions, telling you kind of a function inputs, doing, you know, simple things like bracket tracking. Yeah, and so this is, I think, the easiest interface for beginners to start working with. The kind of default setup, if you look here, you've got a notepad, a console, and then there are these pieces of the environment which help with essentially tracking objects, and this bottom part here is has actually a lot of different sorts of functionalities, and we'll get to that. But the kind of main parts to keep in mind up here in the notepad and down here in the console. If you're working in the console, this is kind of like a calculator area essentially. So I can do operations down here in the console. So simple math, right? I could do 1 plus 2 and hit enter, and it'll spit out the answer down here at the bottom. 1 plus 2 is 3. I can do multiplication, 2 times 3 is 6, and then I can do exponentiation, so 3 caret 4 is 3 to the 4th power. I hit enter, and you're gonna get your answer after you execute, okay? However, any operations that I'm doing down here in the console, it's essentially executed and that's it. None of this stuff is really stored per se. Well, I should be careful when I say that. The inputs here are not kind of being maintained, and so if I wanted to keep track of stuff, I can put it up in my notepad environment here. So I can do 1 plus 2, 2 times 3, 3 to the 4th, right? And so these basic operations are now, you know, it's kind of like a scratch pad, right, where you're keeping things available. And I'll put a note here, basic operations. So this pound symbol, hashtag symbol, whatever you want to call it, that is a way that indicates that any text on that line should be considered a note essentially. And so typically, anytime we're entering text here, you're kind of describing some kind of operation, unless you have that symbol, which will then mean don't worry. It just means don't worry about it, don't interpret it. So I can actually send commands that I'm writing down in the notepad to my console, and the way that you do that is this button right here that says run. The shortcut for this on a Mac is Command Return, and on a PC it'll be Control Enter. Okay, so I can go ahead and execute these, and you'll see that it will send that command down to the console and perform the operation. Questions so far? Is everyone able to follow along? Okay. So next up, storing data as objects. So I can do something like this. Okay, so X, and then I have this caret dash, which is basically just denoting an arrow. This is actually saying for this object X, store the value 2, or assign a value of 2 to it. And so if I send this down, it will execute that command, but actually nothing ends up getting returned. It just is storing that information. And if I wanted to call that object, I can press X here, enter, and it will return the number 2. Okay, so folks who are familiar with, let's say, Python or other programming languages, oftentimes the assignment operator is done like this. So X equals 2. And that actually works in X, or in R. And so I can have X equals 2 here, and I can put X like this, and you'll see that it still keeps that. Or I can show a different number so you can see that that's actually happening. So X equals 1, returns 1. So what I'll say is that the general recommendation when you're operating in R is actually still to do this arrow symbol as opposed to this equal symbol. There is actually a difference. It's a very corner case type of operation, but general practice in R is to use this. Okay. Okay, so let's go back up to here. Yeah, and so I can store a different object as Y, and we can see that indeed that gets stored. Okay, so I'm putting, hopefully people can see, there's a big Y here. What happens when I press enter? What do you guys think?
Nothing.
Nothing. Well, something's gonna happen. Error, yeah. Error, object Y not found. Okay, so R is case sensitive, so that's just something to keep in mind. The capitalization of objects that you're defining, of functions that you're going to be using, it is case sensitive. Okay, I guess I kind of already showed this, but I can assign X as 2 up here, and then I'm going to assign X as 3. And so I put X here, what happens?
3.
3, yes, exactly right. And so you can overwrite and replace the assignment of an object with a new definition, which is what we've done here. Pretty simple to grasp kind of concept, but actually it does have some important implications, right? So, don't accidentally be overriding functions and stuff. Function names with your own things, you can break things like that. And that's kind of maintaining a good, what we call namespace. In your practice here, try and be descriptive about the objects that you are defining. Okay? And kind of as I've shown a couple times already, we can perform, or we can recall objects right? If I type x, it tells me it's 3. And if I do x plus y, what do you guys think will happen? 6. I heard someone say 6, right? So x is assigned to be 3, y is assigned to be 3. When I execute this, it will recall those objects and then return the answer. Okay, so pretty simple so far. Hopefully no problems. So we will talk about functions in a little bit more detail in a second, but I'm kind of going to skip ahead and talk about one very specific function, which is concatenate. Okay. So a function, so if you're not familiar with programming language, it's actually not different from probably the function that you've been taught in like an algebra class, right? So a function is, there's something, so you take an input, you put it into the function, something happens and it gives you an output, okay? And so that's how all functions in R work in most programming languages, right? And the way that we designate a function will usually be like this. Function, here I'll put a generic function operator. So you have the function name, input, and then this returns an output, okay? And again, we'll get into a little bit more detail on this, so don't worry, but apart from the generalization for now. So concatenate function, we've got this C parentheses. If I want to concatenate, it might be something like this. Okay, so what's happening here? Does anyone know what concatenate means? Or what it does? I thought a bunch of you said you guys knew R. Okay, so concatenate basically puts numbers together into a vector, okay? So this is a function, the function name is C, and the inputs are 1, 2, 3, 4. If I execute this, it returns this vector here. 1, 2, 3, 4. And this number that you see right here is an indication of where you are in the index of that vector. Okay, and so for example, there's a shortcut to do, there's a shortcut for doing a vector of numbers if you're doing just a sequence. So if I do like 1 to 50, it'll look like this. And it will return a vector with 50 elements sequentially from 1 to 50. Okay, and so here's your vector, 1 through 50, and then on each line, it indicates the index of that first thing in that line, right? So 1 is the first index, the 17th index is 17, right? It happens to line up because we're going from 1 to 50, but like if I were to do, 57 to, 103, right? So here's our index. The first entry is 57. The 13th entry is 69. The 25th entry is 81, and so on. Okay, so that's what these square brackets are at the beginning. Yes?
It will always be 12 columns.
No.
Well, whatever it ends, it won't.
Huh?
But there's, how is it decided that it's 12, not 10 or 13?
By the width of my window. So here, now it's only 6, right? And then if I go, whoa, over here, it's gonna be like 16 or something, 18. Okay, so it's just how far you stretch the window. Yeah. Anyone else? Okay. Yeah, feel free to interrupt anytime there's a question. Happy to clarify. Okay. So we've done some operations with numbers and with objects that have, numbers that are stored as objects. So what about operations with vectors? Next one. We're gonna make a couple of vectors here. X2 is also 1, 2, and we'll have X3 as 1, 2, 3. Okay, I'm gonna run all those guys. Oh yeah, and so I'll just quickly mention now, remember, I was saying to mainly focus on these 2 windows of your environment. Up here, this window is a way that you can see objects that are stored and what sort of information is in are in that environment that you're storing these objects in. And so far we have defined X, we've defined Y, and then we've defined X1, X2, X3, and you can see right here what those values are being stored as. Sometimes it'll be like a really big table, right? You can't actually see everything, and you can actually just click when it is a table, and it will take you to more like a spreadsheet type environment where you can actually see everything. So it's a nice way to visually be able to view the objects that are stored on your what we call the global environment. Yeah, and so features like this aren't kind of as readily available in the base form of R, again, which is why I recommend using RStudio. Okay, so let's do some operations with vectors. So if I put x1 here, you guys should see, right, 1 and 2, that's what we've defined it as, so let's take a look. X1 minus x2. What do you guys think gets returned?
0.
0, 0.
Just 0?
0, 0.
2 zeros, great. 0, 0, exactly. So what is happening, right, is that you take the first element of your x1 vector and you subtract the first element of your x2 vector, and then you take the second element minus the second element, and so now you have still a vector of length 2 that is 0, 0 for the 2 entries of that vector. Okay. So next up, we're going to do x3 minus x2. Don't enter this yet. What happens? What do you guys think?
Length are the same.
Hmm? So some people say error, some people are saying 0, 0. Okay. Who saw this coming? So it's not an error, it's a warning. And so I'll just quickly mention right now. So there's a difference in R between a warning and an error. An error means that the operation that you're trying to execute cannot be completed, okay? A warning means that it could do it, but maybe there's something weird happening. Maybe it's something that you're probably not expecting, or they're saying that it's like a bad practice type of thing, or some kind of aberrant behavior, but they can still execute it. Okay, so 0, 0, 2. Who expected that? Right, so what is happening here? So we'll do x3 minus x2. So it will look at the x3 vector, first entry 1 minus the first entry of the other one. 1 minus 1 is 0. Next entry, 2 minus 2, 0. Next entry, 3, but there's no corresponding number in the third position of the vector, right? Because x1 is only of length 2. So what is happening is it jumps back to the beginning and repeats, okay? So 3 minus 1. Okay, is that the behavior that you intended? I don't know, maybe. But this will warn you when stuff like that happens. So that's kind of a lesson to keep in mind. That's, when things like, not this exact thing, but in times where you think you're doing something and you expect a certain answer, oftentimes if you're getting a warning message, you need to stop and double check everything, make sure that what you want to be happening is what the program is actually trying to execute, okay? So we can do similar type thing, x2 minus x3, same deal, same issue, it's doing this loop around process. Okay, I can do multiplication, and that should do what you'd expect, x1 times x2. You can do division, right? So same process, it's x1 divided by x2, first element divided by first element, second element divided by second element, and so on. I can do a vector times a constant, and this will simply multiply through across the entire vector, so you'll end up with something like this: 1 times 4, 2 times 4, 3 times 4. Okay. Okay, let me do something like this. So this is x1% times percent x2. I'm gonna hit enter. And the answer is 5. Does anyone know what's going on here? Any ideas?
Dot product.
Yes, exactly. So if I want to do a matrix multiplication, right, there's a difference between doing that versus simple multiplication, right? And so this is doing the dot product. This is here just kind of as a note, so that we're kind of making sure to cover everything. Don't think anyone will ever be using this in this class, but just so you know, it's available. You can do vector operations and matrix operations in R. And there is something different about the way that this number is being displayed. Can anyone tell me what that is? Yes. So you'll note that, right, that when answers have been displayed thus far, we have this this as an identifier for your indexing of my output. Here we have 1 comma and then comma 1. So this is actually returning not just a vector, but a matrix, and so the index is in 2 dimensions with row 1 and column 1. Okay, so in R, it is always row, comma, column. Okay? That's the way that we reference objects in R. That's just kind of the standard. So that's just something that you have to remember. Okay? So R, row, column, RC. Yeah, and you'll have plenty of practice doing that throughout the class. There is so if I take x1 like this, it's currently just being displayed as a vector, and they assume vectors are essentially row objects. If you want to turn it into a column object, you can use the function t, which stands for transpose. And if I hit enter here, oh no, sorry. It will, the vector object doesn't have any dimensions. When you transpose it, it assumes that the vector is a column, not a row. Sorry, I misspoke. It places it into a TD thing where you can observe like where the position is as a row object in the matrix. Okay. We flew through that pretty quick. So, does anyone need me to go over anything again? Any questions? Yes?
Could you re-describe what you just said previously?
Yeah, sorry. Okay, so when I have a x1 object that's this like vector, the vector doesn't assume any position in terms of like a row or column type object. It's just like a string of numbers. Okay, transpose operation is like when I take a matrix and I like flip it, right? When you transpose a vector object, are you going from a column to a row or a row to a column? Well, vectors don't inherently have them, and so when you do a transposition argument to something that isn't defined as a row or column, it has to assume something by default. And so I misspoke. I said that the default was that it was a row, but actually the default is that it's a column, and then when you transpose it, it turns it into a row. Does that make sense? Okay. Anything else? So I'll say generally speaking, I think probably, you know, if you're in like a more engineering discipline and you're like familiar with MATLAB, right, you do a lot more sort of matrix operations. I'm kind of showing that here to introduce like indexing and positioning arguments in R, but we won't honestly be using matrices pretty much at all in this class. So don't worry too much about the exact details of this stuff. Okay, so let's go into talking about functions in R, right? And so these are like the basic tools that we're going to be employing to perform lots of different operations in this class. And you know, we'll talk a little bit about things behind the scenes for a lot of these functions, you know, on the board work, and then we'll kind of show how they can be applied. So you need to have a good grasp of what a function is and what it's doing and how it works. And so the first function, well, okay, I guess I already taught you guys two functions, right? So the concatenate function and the transposition function. But putting those aside, kind of the first function that I'll show is the help function. So if you don't know what a function does, you can just ask for help. Okay, and so the way that help works is, right, all functions need a what? Input, yes. Okay. So the input of the help function is the function I want to know about. Okay, so let's say I didn't know about the concatenate function and I want to learn about it. I'm just going to put in the name of the function, which is C. So help, tell me about C. Enter. Okay. Oh my god, did I have it wrong all these years? It's not concatenate, it's combined. Okay, C, well, it's basically the same thing. Combine values into a vector or list, C. And so one of the things, so I mentioned that we would talk a little bit about what this section of our interface does. One of the things is the help tab, which will display information every time you call the help function. And let me just kind of like walk through this. The format for anytime I put in something into help, it's going to be the same no matter what function I'm asking help about. Okay, so there's going to be a description. This is a generic function which combines arguments, blah, blah, blah. It's going to give usage, okay? So thus far, we've worked with kind of intuitive functions where we just have like this one input, essentially. Or, you know, with C, you know, you have this string of comma inputs. But generally speaking, it's gonna tell you what the inputs need to be. And in fact, there are even options within functions that let you do certain types of settings, and you can change those. And we'll show the more intuitive examples of that in a little bit, right? It tells you the arguments that you need to put into a function. So here's the objects that need to be concatenated. It tells you, should we make it recursive? Should we use top names? We'll cover that later. And then it will give some details about the function, some like notes, and then probably the most useful. So yeah, there's some references and methods and stuff like that. I don't usually pay attention too closely to those things. Probably the most useful is at the end of the help documentation is they give examples and they show you things that you can do with them. And so anytime that you guys are having trouble with a particular function, I highly encourage you to, ask the help function for help. Yes. And so here's a bunch of different sorts of examples. Questions so far? Good. Yes.
I think I had other files open, like you have lecture 1,
Mhm.
I got a couple more,
Yes.
and then I started getting error. So I think it was thinking, is that
Yeah.
Right.
So.
an other environment from other files? Then
Yeah, so you can see here that I'm working on one particular notepad called Lecture 1 in class, but you can actually have multiple environments open. Oh, was that not the shortcut? That was, okay, hang on. Shift, okay. So Command Shift N, and you can see I can open a new notepad. So one thing that you should be cautious of, particularly in RStudio, is you could be working in multiple notepads, and then you could be what's called polluting your namespace. So let's just suppose that I have X in a different file defined as blah, 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 okay? And I have that like executed somewhere, and I forgot that it was executed, and then I go here, and I'm like, oh, X1, or X, and I do X plus Y, oh, error, oh, why didn't that work, right? It's because my X is defined as something else. So one thing to check for you is you can always like go hop on over to this global environment and like just take a look here and are the things defined correctly. I don't know if that's actually what you're running into, but that's
Yeah,
one
no, so
possible.
what I did is just use the broom and you get it.
Yes. Okay, so
And I worry that if I ever wanna use it again for the other note,
yes.
how do I save those three of those two together? And not mix them as I did.
So I generally don't do this, but you can save an environment. How do you do this again? You usually in R, when you quit, it asks if you want to save the thing. I don't know what the actual command is. Hang on. So I don't know if this saves the actual environment.
There's the save under your environment tab.
Here, oh yes, there you go. Yeah, so you can save all the stuff that you've been working on here. Yeah, using that save button. I'm sure there's a shortcut, I can't remember. And it saves it as a .r data file. I never really got in the practice of doing that, but you can. And then when you load it, it'll load in that entire environment.
So say there'll be two separate files.
Yeah.
I can put them in one folder so I know that the one that relates. to
Yeah.
that.
Yep, exactly. Yeah, so that's if you're like working in multiple spaces, that might be a way to stay organized. Any other questions about that? So the next function is ls. So this is a function that will describe all of the objects in my environment. It's the same thing as kind of looking over here and seeing what's stored. It will tell me the names, x, x1, x2, x3, and y of all of the objects in my environment. You guys won't see these first three. So there's some customizability with a lot of this stuff. If you want to preload objects, you can actually do that in R. And I have these set up as a way to like point to specific directory locations on different computers. So don't worry about this. This is like not relevant to you guys. But ls will reveal to you all of the things stored in your global environment. May be relevant for you if you want to get rid of an object. There's a function called rm. Rm stands for remove, and so if I want to remove x, for example, it's blah blah, right? If I type in x here, it will return blah blah. If I rm and put in x, great. So you'll notice it's disappeared from my environment space over there. If I ls, you'll see that x is no longer here. And if I press x, enter, it will say object x not found because we removed it. Okay?
So I deleted the environment and now I have everything you're teaching in the notepad.
Yes?
So my environment is at 0.
Okay.
So I could delete it all, paste it all. Is there a way to get the definitions or
Yeah.
the definitions back in the environment?
Yeah, so I can do rm ls, right? So what's happening here, rm tells me I'm using a function to remove something, and the thing that I'm removing is everything in my global environment, ls. So if I do this, it should delete everything. Okay? Oh, no. Apparently I can't do that. Why can't I do that? Must contain names or character strings.
Why is RM this equals LS?
Because that's okay. Because you are, that's right. So the default setting for RM is it expects one object, but I'm passing a list of objects, and so I actually have to specify that I'm passing it a list and not a single object. Thank you. That's why she's the TA. Okay. Now my environment is gone. And if I want it back, then I gotta run this guy again. So if you wanna run everything, it is, what's the shortcut? I think it's Control-Shift-Enter, I wanna say. Yes. So Control-Shift-Enter will execute your entire notepad. And so you can see here in our global environment, we're repopulated with all of the objects that we have. Yeah? Yeah, and I think the Windows operation is Control-Shift-Enter to do the same thing. Okay. Oop. So let's just blast through a couple more functions. What do you guys think this function does? We're gonna do some intuitive ones, hopefully. It's a mean function. It yells at you. No? Okay, it returns the average, right? And so x3, let's say 1, 2, 3. What do you guys think this will return? 2? Anyone think it won't return 2? Okay, it returned 2. What about now? 1, 2, 3. What do you guys think? 2. And it returned 1. What? Why do you guys think this happened? Give you a hint. I just made this mistake with a different function. x3 is how many objects? 1, 2, 3 is how many objects? 3. So the input is expecting is 1 object. So the first one is the object that it'll look at, and it sees 1, and the average of 1 is 1. Yeah, so that's something to keep in mind, right? And so aberrant behavior, and dangerously, this doesn't even give you a warning. So that can happen sometimes, right? So we do need to be cautious and aware and try and be precise as possible, right? If I want to pass 1 object, you can have the combine function, which will combine this into 1 object, and if I run this, it will be 2. Okay? Hopefully even the people who know R are gonna learn a little bit here today. Length. What do you guys think this does?
The number of items.
Yes, in a vector. Yep, so x3 has 3 objects in it, and if I run it, it gives 3. Cool. Easy enough. We can do n row and n call What do you guys think these do? Yeah, so number of rows, number of columns in an object. Okay, so we will get into data types and certain data structures, and we'll get into like tables and that sort of thing. We haven't really gotten into that yet, so I'm not going to actually execute these, but simple enough. When you put in the table object or data frame object is typically what we call them in R, it will return number of rows and number of columns in an analogous way to how length gives you the number of items in a vector. End row and end call also work for matrices, so if you are doing a matrix, or if you are dealing with a matrix, you want to know how many rows or the number of columns, you can do that as well. Max, min, okay, max, 1, 2, 3, what do you guys think? 3. Yes, that's right, except why is it in this case that it's different from this, right? In this particular case, if I look at the help documentation, it will actually allow you to, in this case, as an input, let me see, where is it? Yeah, numeric or character arguments. So you can actually put multiple arguments in here. But again, probably generally better practice would be to do just one object. In this case it works, right? What we saw in mean, it doesn't. Min, same thing as max, except it gives you the smallest value instead of the largest value. Okay, let's look at a slightly more complex function that actually has a couple of options that you can have in the inputs. Here's another reason why RStudio is a little bit more convenient. It shows when I type in the function, it has this kind of like autocomplete thing or guide that will help you tell you what sort of inputs that you need. Sample. Sample is a nifty function. Not going to say that you're necessarily going to be using it all the time, especially in this class, but it's a useful one to know. Sample is random sampling, okay? So let's take my hat. I have a bunch of numbers in my hat, and I'm going to pull numbers out, okay? That's what random sampling is doing. X is the set of things that I'm sampling from. So if I have a bunch of numbers in my hat, X are the numbers in my hat. Size is how many times I pull a number out of my hat. And replace is whether or not after I take a number out, I put it back in before I draw out another number, okay? So, so the proper way to do this is each of these options are telling you the inputs or the input options, and so you are setting the objects that correspond to each of those things, right? And so if my X is 1 through 50, then what is it that I have in my hat? The number is 1 through 50, okay? And if I want to pull 10 numbers out of my hat, size would be equal to 10. And then if I want to put the number back into the hat every time I pull one out, then I have to say replace equals true. Okay, so if I run this, you'll see it's pulled out 10 numbers that are between 1 and 50, and they look like this. Okay, not in this case. So we'll try again. Okay, cool. So when I execute this command again, it is a random number generator, and so I will not have the same numbers come out. And because I specified replace equals true, you could get the same number. And that happened in this particular case. Okay, I'm gonna do this again. X equals 1 to 50, and I'm gonna draw 51 numbers out of the hat. What's gonna happen? Anyone? Error. Yes, that's right. I tried to take 51 numbers out of the hat that only had 50 numbers, so it doesn't work. And that is because we did not specify the replace equals true, which means that you put the number back into the hat before you pull a number out again. So you run out of numbers to pull. And if I do this again in this autocomplete, one of the things you'll notice is that for these options, sometimes you have this equals option, which means that there's a preset. And if you don't change that preset, that's the default setting for any particular option. And so the default setting for sample is to do it without replacement, which means that you don't put the number back in the hat. And therefore, our line 50 failed. But if I do this with replace equals true, it now means that I'm putting the numbers back in the hat, and I can execute this, and it will run, and in fact, you're going to be guaranteed to have at least one overlapping number, right? So yeah, 11 and 11. Okay, any questions about that? So, with this particular example, right, I'm teaching you about the sample function, but I'm also teaching you about function options, which are going to be an important thing to keep in mind as we work through different sorts of functions in this class. All right, continuing on. Let's say I need to make a function, or let's say I need to define a vector with a bunch of ones. I'm gonna have to do this a bunch of times. It's kind of a hassle. Luckily, there's a function for that called rep. So I don't know how many ones that is, but let's say that's like 15 ones. So I can do rep, and there's a couple settings in here. So there's x and there's n. So x is the thing that I want to repeat. In this case, it's going to be 1, and n is the number of times I want to repeat it. So 15. Wait, it's the other way around. I think I would know this by now. Times, sorry, not n. Okay. So, 2 input options, the object that I'm repeating, and the number of times I'm going to repeat it. Okay? We can actually do this with vectors as well. So x equals C 1, 2, 3, and I want to repeat this 4 times. So I will generate a vector 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, looks like this. If you want to repeat specific elements of a vector, you can do that as well. So 1, 2, 3, and the option to do that is called each. So each element is going to get repeated 3 times. So then you have 1, 1, 1, 2, 2, 2, 3, 3, 3. Okay? And if you really want, you can do both. So I want to repeat each one 3 times, and I want to do that for total times. Okay? So try and visualize what you think is going to happen here. When I execute this particular argument, where I'm doing both times and each, ends up being something like this. So I get 1, 1, 1, 1, 1, 2, 2, 2, 3, 3, 3, in the same way that I got each equals 3, and that whole string gets repeated 4 times. Right? So group of ones, first group of ones, second group of ones, third group of ones, fourth group of ones. Okay? This is a decently handy function. You may find yourself using this occasionally. So I showed a shortcut to do these vectors like 1 through 50, right? Instead of typing C 1, 2, 3, 4, 5, 6, dot, 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 50. So this is a nice short way of doing that. There is a more nuanced function that you can use to do this that's a little bit more customizable, and that's called SEQ, or sequence. So it has 3 arguments. We'll start with the first 2, which is start and end. And so I could do something like 1 to 50, and that will execute the same thing as the 1 colon 50. Oh, no. Thought I did that. 1 comma 50. Did not start. Oh, no, sorry. Okay, that's my own notes of just the starting and ending. Okay, so 1 comma 50 does the same thing. So why would we do this? Well, the sequence function is a little bit more customizable, like I was saying. So if I wanted to go from 1 to 50 in increments of 0.25, I can do that like so. Okay, and we can go something like this. And this will bring you from 1 to 50 in those increments. And in fact, I think we can even go backwards, something like this, right? And so I can go back from 50 to 1 in increments of -1. Okay. Any questions so far? The last couple ones that I'll show, or the last one that I'll show for now, is a function called unique. And this will essentially, any object that you put into it, it will return all of the unique objects. And so anything that's repeated will get dropped, okay? And so let's set this as repeating values. So I'm gonna create an object called repeating values. And that object is that thing that we made earlier. So 111, 222, 333, 4 times, okay? And if I put repeating values, the object repeating values into unique, what gets returned? What do you guys think? 1, 2, 3. That's right. So it will just take the unique values. Anything that's repeated will get discarded. So even though you have a much longer vector with many repeating values, unique will drop those repeating values. Okay. So those are a couple of handy functions, and obviously we're going to cover more as the class goes on. A lot of them are going to be sort of applicable directly to the tools that we're using or developing. But there's one important thing that we need to talk about, and that is building custom functions. Okay, and so all of these functions, right? You are doing inputs and getting some kind of output. We can make our own functions, and in fact, you guys are going to be doing that quite a lot in this class. And yeah, let's just do an example of something. So the syntax to build your own function is start with the function name. So the function I'm going to create right now is I'm the real mean. And we define this as a function object, like so. Okay, so this is an object called I'm the real mean, which we're defining to be a function with a specific input. Okay. Okay, how do I calculate a mean or an average? I know you guys know this.
I don't know the numbers, divide by the number.
Add up the numbers. Okay. So go ahead, say it again out loud.
Add up all of the numbers
Okay.
and divide by the number of values.
Okay, great. Add up the numbers. We'll do this step by step, okay? So actually, this is really good practice. I know that this is like exceedingly simple, right? And I'm sure for all the folks here who are from comp sci, this is like, this is very, very basic, but this is actually really good practice, right? So thinking about what you want to do in English and then like translating that into code, right? So we all know how to take an average, right? So you add up all the numbers, so that's step 1. So we're gonna sum all of the numbers. So this is actually a function we haven't covered yet, sum. You can guess what it does. We're gonna take our input and add it all up. So that's their that is our numerator, and the denominator is what? How would we get the denominator with the tools that we've talked about so far? Length, exactly. So we have a function that will tell us how many elements there are in a vector. That's the length one. So like so. And then what's the last thing that we need to do? Divide them. So z is x divided by y. Okay, and so what ends up happening when you create a function, you have an input, you run the function, and then it's going to execute these things inside of here. And then the last thing is in a function, you have inputs and you have outputs. So what you want the function to return is your output, and that is done via this procedure, this function actually. It's called return. So please spit back to me object z, which is x divided by y. Okay? run this guy. Okay, so now I have stored in here a new object. Here, it's a function. It's called I'm the real mean. Okay, and you can see that in our global environments. What do you guys think happens here? Error. Yes, good. If you think about the way we've defined the function, it's asking for one input, and we've put in 3 objects, right? So, great. Did not work. Now it's 1 object. Yay, okay. So we just designed our own function that does average, so 2. Does anyone notice anything interesting happening here? Let me give a little bit more of a hint. So look at the object assignment here. When we run this guy, or sorry, I'll put it in the notepad. When we run this guy, let's just do it like manually. C123. So x is the sum of 1, 2, 3. What's the sum of 1, 2, 3? 6. I think I heard someone say 6. Thank you. Okay, I'm gonna put x here, and I'm gonna hit enter, and it's gonna return what?
3.
Not 6. What's happening? Anything inside of a function lives in a different world, okay? That is known as a local environment, not a global environment. And so that means that whatever happens in the function stays in the function, okay? And so you're not overwriting things in your global environment when you do something like this. I will say, however, we'll say for like a best practices perspective, you still want to usually avoid this type of thing where you're using like similar object names both in locally and globally. It can get confusing, and you can run into these like potentially namespace problems. Okay, I don't know why I tell people about this, because you should never ever do this. Like really, you should never do this. But if you really want your global, if you really want stuff in here to affect your global environment, you can actually do that. Okay. So if I do double caret in my arrow, it means whatever is happening in the function no longer stays in the function. Okay. So it's going to define x globally when you do this. So this is a way that you can actually do that. And in fact, if I run this again, I still get the same answer. Wait a minute. Oh, yes. Okay, I gotta redefine the function. Thank you. Doing this on the spot is always tricky. Okay, I rerun it. And what do you guys see? X here has been redefined to be 6. So now what's getting written locally is actually affecting your global namespace. Just never do this, okay? I don't know why I tell people about this every year, but just don't do it. Bad practice. It's not even gonna show up in the notes. Okay. Cool, still got time. let me pause for a second. Yeah, we're flying through a lot of stuff here, so happy to take any questions. If anyone wants me to recover anything, happy to do that right now. Last chance. Okay, moving on. Next thing we're going to talk about, looping. Okay, so a loop is actually kind of like a special type of function where we are executing a specific command in a loop. So you're doing it over and over again a certain number of times. In a for loop, we are running through a procedure that's getting defined here. And so what happens is you can imagine that if you think of this as kind of a function, and stuff in here is like a procedure that's happening. It's going to run through that procedure a predefined number of times. In this particular case, it's going to run through it 10 times. And what's happening is it's going to run through it once, and it's going to set x equal to 1 the first time it runs through it, then 2 the next time, and 3 the next time, and so on and so forth until it runs through what's kind of defined here. And so, if I do something like this, print x, and I run this thing, you'll see that it's going to print out the numbers 1, 2, 3, 4, 5 as I loop through this procedure again and again. Okay, so this is a pretty powerful procedure that's pretty handy to do a lot of different things. So we can show a example of the power of doing a loop. So let's see, what does this do? Oh wait, I need to cover, why is this out of order? One moment. Before we do this, I have to cover if statements, which for some reason is missing. Okay, 1 second. All right, don't know how that happened. Okay, we'll come back to this function, but we need to, before I do this, okay. So another thing we need to cover are if statements and slash bar statements. So these are very standard and very practical tools to be able to use in data analysis. If I'm doing any sort of like data filtering, these are very handy tools to be able to use. So there is a certain type of data structure in R, which is just a logical. It's a Boolean true or false. You can think of it as like a 1 or 0. And if statements and and/or statements are one sort of powerful way of exploiting these sort of conditionals. Okay, so let me do something like this. I'm going to go back to x is 3. So if x is 3, print true. Okay, we're gonna hit a couple of things here. So first off is there is this conditional check. So equals and equals equals are two different things. So equals is the same as the arrow thing. It's an assignment operator which will overwrite. Right? It'll tell you to assign a particular thing to an object. That's different from two equals, which is a check to see if the things on both sides of my equals equals are the same as each other. And if I do x equals 3, it will return true, and x equals 2 will return false. Okay? Any questions about that? So that's kind of the basic operator for an if statement that's already kind of built in, but we can do more complex things here, right? And so if basically what the if statement is looking for is, if this is true, then it will enter into the if statement. And this is like a logical thing, right? Do not enter into the if statement when you have something like this. And in fact, if you have an else thing, then it'll enter into to do that instead. Okay. So what is happening here is that in an if statement, if the condition holds true, you can have some kind of operation in here that will get executed. Otherwise, you might have a different sort of operation in the else part that will get operated, and you only enter into the if statement if the condition in here is true, and if it's false, then you won't enter into it, right? So let's do an example of this. So it wasn't true, and we made it. Okay. So if you make it into here, then you'll print this thing. Otherwise, it's gonna go into this thing. What do you guys think will get printed if I have x equals 3?
Nothing.
It's either we made it or it wasn't true.
We made it.
We made it. Great. And if it's not that, then we get it wasn't true. So I was mentioning, right, that in here is where we can start to get more complex conditionals. So I'm going to introduce and or operators, which you can leverage in combination to check like multiple things. And everybody here knows this, okay? Even if you haven't done any programming before, okay? Raise your hand if you are wearing a shirt. Everyone should raise their hand. Okay, so everyone's raising their hand. Raise your hand if you are wearing glasses. Okay? Raise your hand if you are wearing a shirt or if you are wearing glasses. And then raise your hand if you're wearing a shirt and you are wearing glasses. Okay? Everybody knows how this works, right? So and means that both conditions have to be fulfilled when it's true, right? And or is only one of those conditions has to be true. So you can, I think you can pretty sort of easily logic your way through this. And so, you know, if x is equal to 3, or is x equal to 3 and is y equal to, let's say, 4. Okay. Is the thing inside of the if parentheses, is that true or false?
False.
It's false, right? So you have a true and a false, which makes it false. And then if you want to do or, it is the vertical line. Is this true or false? You have one true or a false. So it's true. Okay? So we made it. Yeah, so the if statement and the conditionals that are associated with it are a pretty powerful filtering operator that you guys will almost certainly be using throughout the class. So it'll be important to kind of get this stuff straight, and you'll have some opportunity to practice this in your homework. Okay, so having covered that, I am going to copy and paste a function here. Okay. Comp sci people, don't answer this. This is a function, it's a mystery function, it's called what does this do? And this is like combining like a bunch of different functions and tools that we've covered in this class so far. And I know, especially for those who are newer to programming, this is like pretty accelerated. So it can be challenging to kind of like just stare at a function immediately and be able to tell what it does. And so we need to come up with a sort of procedure, right? A tool in which we can kind of walk through this more easily to try and decipher this. So there's going to be a little bit of this in this class where I'm going to be asking you guys to build your own functions and to interpret certain functions. So this is a skill that's going to come with a little bit of practice. Don't get frustrated like if you can't like get this immediately. Okay? So we've got this function, right? And just remember, we've got an input and an output. And one of the ways that I think they teach you to kind of interpret a function is just to kind of like walk through it, okay? And so let's do that. So I'm actually going to use a little bit of board work for today to do this. So one of the ways that you can try and figure out what a function is, what a function does, is to just like put in a number and like walk through it and see what happens. Okay. So let me execute this. What does this do? And I'm going to put in the number 1, and it returns false. And I'm going to put the number 2, false, 3, 4, 5. Okay, so not exactly sure what it does yet, but it is. Anytime I'm putting a number in, it is returning a boolean of true or false. So let's see what happens. Let's start with x equals 4 for a second. So we'll have a table here. So this is our first input. Okay, 4. So let's jump into the function. If x is less than 2, return false. Okay, so is x less than 2 in this case? No. And so we're just going to move right on to the next part. So we never enter this if statement. So for n in 2 through x minus 1. Okay, so that's for n in 2 to 4 minus 1. So it's going to run into a for loop, right? And in fact, we'll have something like this. So it'll go 2 and 3. So when n is 2, something's going to happen. And then when n is 3, something's going to happen. Possibly, because there's actually another if statement. Okay, there's actually a new thing that we haven't learned, x %%. Does anyone know what %% does? Or can guess?
Is it a remainder?
Yes, that's right. It's called the modulus operator, which gives you the remainder. So 5 divided by 2 has what remainder? 1, right? So 10 mod 3, or let's say 10 mod 4, so 10 divided by 4 is 2 remainder 2, so that's 2, okay? So it's saying x divided by 2, what's the remainder? Is it equal to 0? So in fact, what is 4 mod 2? 0. So 0 is 0 equal to 0? It is. So we enter into the if statement and we get to the return. So the return is false and you stop. So I should mention that anytime you hit return in a function, it ends. That's it. It means that, I've arrived at where I want to put the output. The output is false, and so I never even get to n of 3. Okay? Okay, so now let's put in 5. Not less than 2, jump ahead to the for loop, and my n is 2 through 5 minus 1, so 2 through 4. So 2, 3, 4. Does 5 divided by 2 have a 0 remainder? No, so we So we'll skip that and go to the next loop. Does 5 divided by 3 have a 0 remainder? No. So we go through that one. Does 5 divided by 4 have a 0 remainder? No. So we'll skip that one. And so we've made it through all of these guys, and now we're at the end of our for loop, and then we will end up returning true at the end. Okay? And so you could continue to do this and try and essentially figure out what's happening, right? And so what is this function doing? It's trying to find whether or not you have a remainder as you go from 2 up to that number. What do you guys think?
Checking if it's a prime.
Yes, exactly. So this function we call is prime, okay? So I can simply check whether or not any particular number is a prime number. Is 5 a prime number? Yes. Is 7 a prime number? Yes. Is 9 a prime number? No. Okay? So you can see that we are able to kind of customize functions in complex ways to do more complicated tasks. Let me do something else here. Don't worry about copying this code. So this is executing our isPrime function on this number. It is 99,999,000. So is 99,999,989 a prime number? Okay. And actually, what I'm executing here is a way to measure time, essentially. How long does it take for a particular thing to execute? So you grab the system time and then you subtract it from the, you take the system time after you run the function, you subtract it from what the system time was before, and it tells you what that difference is. So I'll run this. We will twiddle our thumbs for a little bit. Okay. So this function took 7.6 seconds to run. Kind of a long time in computer speak, right? So one of the things to keep in mind in sort of practice is when we're doing any sort of application, you do want to think about the complexity of a particular operation and whether or not there are like ways to simplify it. Okay. Is there a better way to write this function? What do you guys think? Probably. Why would I be asking this question if there wasn't? In order to check if this is a prime number, it is checking basically from 2 through that number, right? Do we need to do that if it's a prime number? No. So what do we need to do? What would we need to check? A smaller subset of numbers? What would that smaller subset of numbers be?
Odd numbers?
Huh?
You can just do odd numbers.
Sorry?
Odd numbers?
No, because then 16 would be a prime number, right? 4 times 4, and no odd number combinations will multiply to 16. 25. If I'm gonna check, if I divide by 2, we're okay. Not divisible. 3, no. 4 is no good. Well, actually, let's do this. Let's do an actual prime number. 29. 5 is not divisible. 6, right? And I could go all the way up
Only
to 29. Yeah, only.
like by one odd number and one pair.
No, not quite, because right, like prime numbers can be products of combinations of odds and evens, or both, right? So, do I need to go past 6?
No, like
Why?
they repeat.
Right, because anything that I would be multiplied on here would this would account for all the numbers on the other side, right? So you actually never need to go above the square root of that number. You don't need to check for anything bigger than the square root of that number. Does that make sense to everybody? Think about it. Okay. And so we can actually construct a function that I will call is prime better. And this function is exactly the same as the other function, except that we only go up to the square root of the number instead of the actual, instead of going all the way up to that number. Okay? And you think, okay, well, so you've reduced the size of numbers that it needs to get to. And in fact, if I go ahead and grab my little timing function again, and we look for the same number, oh, sorry. That's kind of interesting. 0.008 seconds. So to calculate the exact same number, whether that's a prime, this function is 1, 2, 3, 1, 2, 3. It's 1,000 times faster, okay, with like one simple change. And so some of these efficiency differences are can be very powerful. So this is a concept that we think about called big O, and that has to do with, if you think about the size of your input, right? In the first example, it's growing linearly with the size of this number, whereas in the second example, it's growing with the square root, so much smaller. And in fact, you'll get bigger and bigger efficiency gains the larger this number gets because of that. You only need to estimate a fraction of the number here as opposed to the other example. So principally, it's just something that you might want to consider in this class, especially if you're sort of dealing with larger and larger data sets. That if that concept kind of comes into play, you should look for ways to make things a little bit more efficient. And I just want to have that as kind of a general advice or guidance for you without giving like specific practices on how to do that, but it's something that you should be aware of, and I'm happy to help with if anyone is running into like computational complexity issues. Okay, great, so we'll end here for today. Yeah, and so I know, again, this is a class with people from a lot of different backgrounds. I'm sure this is review for some people. I'm sure this is really fast for other people. Once we get our foundation set this week, we'll dive into the actual data analysis stuff starting next week. So, yeah, thanks all. And if you have any questions.